Okay, in this tutorial, I'm going to talk to you about glaciers and ice sheets, what they are and what the difference between them is. Okay, now both of them are associated with glacial periods of our planet's history. So this is a time when the planet's temperatures are much colder than they are today, not just for a few years, but for thousands of years. Okay, and the first thing you've got to understand about the way it works during an ice age is it works a lot like it does right now. So we have winters and we have summers, and of course that's just to do with the seasons and our orbit around the sun. The difference is that in an ice age, the summer is slightly cooler than our current summers are, and the winters are colder. Now, what that means is that when it snows, as it does in mountainous areas and in areas that are near the top of the planet, in the Arctic, and areas that are in the bottom of the planet near the Antarctic, when it snows, more snow will fall, and that's because the winters are colder. Another thing is that when summer arrives in an ice age, because it's a cooler summer, a lot of that snow will not melt. So the snow that falls in the mountains around the planet will often not melt during an ice age, and certainly the snow that falls in the Arctic and the Antarctic certainly will not melt either. Now, what that means is because the lower temperatures last for thousands of years, as identified by Milankovitch, the snow starts to build up. So just imagine it snowed today in Scotland, and that snow was to not melt. And then it was to snow again next winter. But over the summer, the snow didn't melt. Now, if you start adding it up, it's a bit like putting bits of paper, lying them down on the table and laying another piece of paper on top and another piece of paper on top. Each piece of paper represents a snowfall. Over time, layers and layers of snowfall will start to build up and get higher and higher. And if you start multiplying that into thousands of years, you can see that the layers of snow can become hundreds, if not thousands of meters thick, given a long period of time. Now, of course, it doesn't remain as snow. What starts to happen is the layers that fell a long time ago that are now on the bottom start to get squeezed and pressed. And all of the air in the snow gets forced out, and that snow turns to ice. So let's have a little look at what that actually looks like, because even though we are in an interglacial period of time, which is a warmer period of the planet's history, we have an entire continent, Antarctica, that is buried under an ice sheet. Okay, and this ice sheet is so large that it doesn't just cover the continent itself, which we cannot see because it's buried by the ice, but it actually covers the surrounding sea as well. There are only a few areas of Antarctica we can actually see, and these tend to be the mountainous areas that are so high, like these mountains, that the peaks just appear above the ice sheet. Okay. Most of the mountains, though, are actually underneath. Here we can zoom in, we can see parts of a mountain that are tall enough. And these mountains are bigger than the Alps in Europe, but the majority of this mountain is under the ice sheet. So ice sheets remain both at the bottom of our planet, and that's because obviously the South Pole is the coldest, one of the coldest regions of our planet. And the only other place where we can find an ice sheet still today in 2021 is on the piece of land that we call Greenland. And it's a smaller ice sheet, and the edges of Greenland can actually be seen. There are about 50,000 people live on the edges of Greenland. We don't have any ice sheets on the actual North Pole because the North Pole is an ocean. It's not a continent like Antarctica. But this area does freeze in winter especially. But it's not an ice sheet, it's just frozen ocean. So it's a little bit different from an ice sheet. And it's obviously floating on the top of an ocean and moving all the time. So there's a difference between the Arctic Ocean being frozen and this ice sheet here. Right, that's ice sheets. Let's just very quickly talk about the other key feature. And this is the one we're going to be mainly looking at in this topic. And these are glaciers. Now, glaciers are found in mountainous areas of our planet, and they can actually be found everywhere, including in Africa. And even though Africa is very warm, anywhere where you've got a mountain, because the land is much higher, the temperatures at the top of the mountain are very cold. So the same thing happens in mountainous areas as it happens in the Arctic and the Antarctic. When snow falls, it doesn't melt, and that's just because it's higher and the temperatures are lower. So over time, this snow builds up, certainly near the tops of mountains, and continues to build up, and we'll be looking at more of this on next lesson, to form what we know as a glacier. And here we can see in the Alps of Europe, a very large glacier. And I'm looking at an aerial view, so I'm like a bird flying on top of this landscape, and I can see this glacier. It's actually got lots of birthplaces. We'll be looking at all of these key ideas in this topic. But here is our main glacier, and it's like a river of ice, but it's not ice, it's kind of frozen snow, I guess is the best way of describing it. And it's moving because of gravity. And it's the movement of this glacier through this mountain range which creates all of the main features that we're going to be studying in this topic. And this is the thing that happened to Scotland during the last ice age. We were covered not just in a large ice sheet, but we also had many of these glaciers, especially towards the end of the last ice age, which shaped all of the landscape features we see all across Scotland. Okay, so to summarize, we've got ice sheets and glaciers. Ice sheets are large pieces of ice that cover entire landscapes and are found in Greenland and Antarctica. And glaciers are small areas of ice that are confined within valleys, and they travel downwards out of mountain ranges because of gravity.